National Electrical Code Section 334.12 addresses uses not permitted for non-metallic sheath cable, commonly known as Romex. The specific part of 334.12 mention states that cable shall not be used as an open run in dropped or suspended ceilings in other than one or two family dwellings. Understanding the scope of National Electrical Code Section 334.12 is crucial for ensuring electrical installations are safe and compliant. The exception for one or two family dwellings indicates a specific allowance for residential applications that doesn't automatically extend to other types of buildings. The National Electrical Code defines dwelling unit as a single unit providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. This definition emphasizes the residential nature of dwellings, differentiating them from commercial or industrial spaces. The term open run refers to cable that is exposed and not enclosed in conduit or other protective raceways. This means the cable is visible and accessible without removing any building finish or structure. In the context of dropped or suspended ceilings, an open run would be cable that is simply laid across the ceiling grid or attached to the ceiling structure without any additional protection. Commercial buildings generally fall under different code requirements compared to residential buildings due to the varying occupancy types, fire safety considerations, and potential electrical loads. Commercial spaces often have more complex electrical systems to support lighting, HVAC, and equipment loads. National Electrical Code Section 300.3 provides an overview of the types of buildings covered by the code, including industrial and office buildings. This section establishes the broad scope of the code's applicability to different building types. Industrial buildings are typically structures used for manufacturing, processing, or storage of goods. These buildings often have specialized electrical requirements to support heavy machinery, equipment, and industrial processes. Office buildings are used for administrative, professional, or clerical services. Electrical systems in office buildings typically support lighting, computers, and other office equipment. The distinction between residential and commercial buildings is important because the National Electrical Code addresses each type of building separately with specific requirements tailored to the unique characteristics of each. This ensures that electrical installations are appropriate for the intended use and occupancy of the building. If you are running Romex in a one-story commercial steel building with small wood-framed offices and stapling it to the bottom of the joist above a drop ceiling, the key question is whether National Electrical Code Section 334.12 applies. Based on the code language, this section does not apply to commercial buildings. However, other code requirements may still apply to the installation. Firstly, consider National Electrical Code Section 300.4, which covers protection against physical damage. This section requires that cables be protected from physical damage where exposed. In a commercial building, this may mean that Romex needs to be installed in conduit or otherwise protected from potential damage from equipment, personnel, or other hazards. Secondly, check National Electrical Code Section 334.15, which addresses securing and supporting non-metallic sheath cable. This section specifies how Romex must be supported and secured to the building structure. The cable must be supported at intervals not exceeding 4 1/2 feet and secured within 12 inches of boxes, cabinets, and fittings. Thirdly, consider local amendments to the National Electrical Code. Many jurisdictions adopt the National Electrical Code but may also add their own amendments or modifications. These local amendments can be more stringent than the National Electrical Code and may affect the installation of Romex in commercial buildings. Fourthly, ensure compliance with National Electrical Code Section 300.11, which covers securing and supporting wiring. This section requires that wiring be securely fastened to the building structure. In a dropped or suspended ceiling, this may mean using approved methods for supporting the cable from the ceiling structure. Fifthly, review National Electrical Code Section 310.15, which addresses ampacity of conductors. This section specifies the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. It's important to ensure that the Romex is properly sized for the intended load and that the installation complies with the ampacity requirements. Sixthly, consider the fire rating of the ceiling assembly. In some commercial buildings, the ceiling assembly may be required to have a specific fire rating. Installing Romex in the ceiling may affect the fire rating of the assembly, so it's important to ensure that the installation complies with the fire resistance requirements. Seventhly, verify compliance with National Electrical Code Section 314.17, which covers the use of boxes and fittings where conductors enter or exit a box or fitting. This section requires that the conductors be protected from abrasion and that the box or fitting be properly secured. Eighthly, review National Electrical Code Chapter 5, which covers special occupancies. Depending on the nature of the commercial building, there may be specific requirements for electrical installations in hazardous locations, healthcare facilities, or other special occupancies. Ninthly, consult with the qualified electrical inspector. The electrical inspector is the final authority on code compliance and can provide guidance on specific installation requirements. It's always a good idea to consult with the inspector before starting the installation to ensure that the work will be approved. Tenthly, consider the long-term maintenance and accessibility of the wiring. In a commercial building, it's important to ensure that the wiring is accessible for maintenance and repairs. This may mean using junction boxes or other access points to facilitate future work. The decision to run Romex above a drop ceiling in a commercial building should be based on a thorough understanding of the National Electrical Code, local amendments, and the specific requirements of the building. While National Electrical Code Section 334.12A may not prohibit the use of Romex in this application, other code requirements may apply. In steel-framed commercial buildings, it's common to run electrical wiring within the wall cavities or above suspended ceilings to conceal the wiring and protect it from physical damage. However, the specific method of installation must comply with the National Electrical Code and any applicable local amendments. The use of staples to secure the Romex to the bottom of the joist is generally acceptable, provided that the staples are approved for use with Romex and that the cable is supported at the required intervals. However, it's important to ensure that the staples do not damage the cable insulation. It's also important to consider the potential for the cable to be damaged by screws or nails used to install the drop ceiling. To prevent this, the cable should be installed in a way that minimizes the risk of contact with these fasteners. One option is to run the Romex through conduit or other protective raceway. This will provide additional protection for the cable and help to ensure that it complies with the National Electrical Code requirements for physical protection. Another option is to install the Romex in a cable tray or basket. This will provide support for the cable and help to prevent it from sagging or becoming damaged. Cable trays and baskets are commonly used in commercial buildings to support large runs of cable. The National Electrical Code contains specific requirements for the installation of cable trays and baskets, so it's important to ensure that the installation complies with these requirements. In addition to the National Electrical Code, local building codes may also have specific requirements for electrical installations in commercial buildings. It's important to check with the local building department to ensure that the installation complies with all applicable codes and regulations. The decision to use Romex in a commercial building should be based on a careful evaluation of the building's specific electrical needs, the applicable codes and regulations, and the potential for physical damage to the cable. If there is any doubt about the suitability of Romex for a particular application, it's always best to consult with a qualified electrical contractor or engineer. They can assess the situation and recommend the most appropriate wiring method. Steel buildings present unique challenges for electrical installations due to the conductive nature of the steel. It's important to ensure that all electrical equipment is properly grounded to prevent electrical shock hazards. The National Electrical Code contains specific requirements for grounding electrical systems in steel buildings. These requirements are designed to ensure that the building's steel structure is properly grounded and that any fault current will be safely conducted back to the source. In addition to grounding, it's also important to consider the potential for electromagnetic interference in steel buildings. Steel can act as a shield, blocking electromagnetic signals. This can affect the performance of wireless devices and other electronic equipment. To mitigate this, it may be necessary to install special shielding or filtering equipment. The installation of electrical wiring in commercial buildings is a complex process that requires careful planning and execution. It's important to work with a qualified electrical contractor who has experience in commercial electrical installations. They can ensure that the installation complies with all applicable codes and regulations and that the building's electrical system is safe and reliable. When working with electrical wiring, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. Electrical work can be dangerous, so it's important to take all necessary precautions to prevent electrical shock and other injuries. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical contractor or engineer before starting any electrical work.